Okay, my name is Krasi. I have seen many people read it as crazy, and I don't mind. It fits very well with the things I like to do in my weekends, so that's fine. Prometheus maintainer from March this year, and since then I managed to fix and break quite a few things already. Work as part of the Prometheus team in Red Hat, which means mainly fixing bugs and adding features upstream. In Red Hat, Prometheus is used in OpenShift, of course, Kiali, which is a new open source project for monitoring and tracing of containers, and as far as I know, in the operations monitoring. Harsh, who is here with me today, he's an undergraduate student from the Indian Institute of Technology of Hyderabad, who decided to help us through the Google Summer of Code. So it's great to have him here. So now, back to the main part. Everybody wants stable software, right? But how do we know it's stable? Well, in Prometheus' case, that means running it long enough at high load, comparing it with another version, and then the results should give us the answer if it's ready for another release or it needs more work to be done. Well, the project is not 100% there yet, but we're very, very close. And the funny story is that when I submitted the talk, this was just an idea and maybe some discussions, but when I received the email one day saying, your talk is accepted, and I thought, oh, no, now I really have to do it. So lucky for me, Harsh also liked the idea and decided to help us, so I thought, well, two is a team, so there is no excuse, we can do it, no problem. So let me see some hands. How many of you are some sort of like maintainers or open source project maintainers? Okay. So you will like I promise you will like the next few slides. This is what a normal day looks like for me. That's just before I look at the GitHub homepage, hoping to see a PR that is only a single line and it fixes at least 2 or 3 bugs. But this is what I get next. Now this might sound and look familiar to many of you. Usually it starts, my Prometheus is broken, please help. So here I keep it calm, trying to ask for more details. Hey man, I'm not a psychic, give me some detail. And this is what I get next. That's like a huge config, which is supposed to work on like amazing 300 and 3,500 targets. Now, don't get me wrong, this is amazing. I mean, Prometheus can handle that, but how do I replicate this locally, right? Well, benchmarking. And, okay, let me see some hands. How many of you use 2.1 or 2.2 version? Okay, I feel your pain. There were quite a few, there were a few memory leaks and few crashes based on compactions. So, but Golang is garbage collected, right? So how can there be memory leaks? Well, what happens is that when the application generates more garbage than what the garbage collector can collect, then the garbage collector can clear, then over time, the memory usage grows so much until the system just kills the application. And the next one was with compaction. Now in Prometheus, the database is separated into folders by a time range, 2 hours, 4 hours, 10 hours, and so on. And compaction is when 2 or more smaller blocks are joined into a bigger one. And if the system runs out of memory during this compaction, then next time Prometheus starts, it was game over. It would go into a crash loop with some overlapping ranges, errors. Both of these are fixed in 2.3. But anyway, my point is, why don't we just do unit testing and end-to-end tests? Well, none of these will appear in unit testing and end-to-end tests only because they run for a very short period of time and with hardly any load. So now that you see why we need benchmarking, let's see how we did it. After a long discussion, we decided to use Prow CI, which is developed and maintained by the Kubernetes testing team. It runs on Kubernetes, which is great because most of the maintainers are familiar with Kubernetes. It integrates nicely with GitHub, so we can trigger jobs by a single comment, which is easy. It's written in Golang, so that's a big win for me. And it's very easy to extend using plugins, which is what we did. We implemented one for our use case. It's not as popular as Drone, which is another continuous integration tool, but it's still used by quite a few projects out there. Now, before we even decided what to use, there were like 2 months of discussions, and with PromCon approaching and the talk being accepted, that's really helped to get us nervous and speed up the process. So I think we had it done in another 1 or 2 months. Now, another tool that we were considered was Drone CI, and it's great, but it was missing two of the main features that we needed, namely comments, and it runs on Kubernetes, but it's kind of hacky. Packet, which is a cloud on bare metal provider, is what we used at the beginning. Their team is great. The API is amazing, so big thanks to their team. But one day on IRC, I think Julius or Fabian mentioned, why don't we just use the managed Google Kubernetes engine? This will save us a lot of hassle and maintenance. And I think they were right. I was thinking, should I rather spend my weekend fixing a Kubernetes cluster, or should I do something else crazy that might kill me or something? I don't know. So at the end, Terraform. Why don't we use Terraform or any other more generic tool? Well, I thought I would rather write a few lines of Golang code that will do exactly what I need, rather than learn another 2 or 3 tools that will do exactly the same thing. And life is too short, right? I mean, if I was a teenager, that's fine to experiment, but these days, that's too much. So at the end, I think it was the right decision, but time will tell. The PromBench tool ended up being really easy to use. It doesn't need any dependency, it doesn't need kube control or anything else. It's written in Golang. You just download it, create an account with the Google Kubernetes engine, download the authentication file, run it with a config for the machines that you need to run, and the 2 versions of Prometheus you want to test. So now, let me see some hands. How many of you want to see a recorded demo? Shame on you. We're doing it live. We feel adventurous. So now let's see what's on the PR's queue. That one looks interesting. And it's one of the top contributors, so it must be good. Let's see what we have here. Well, that's just removing some buffer, so it must be okay. These are not important. And I'm thinking, since we have so many maintainers here, should I just click on merge, or should we run a test? What do you think, Brian? I don't know, we feel adventurous. Okay, well, let's run a test anyway. I'm sure it will be fine, but let's see. Did I type it right? My screen shows completely different thing. Okay. So now if everything goes well, in a second we should receive a response from the Prow system that a test has been started. Can you just scroll back a little bit? Scroll up. Up. The other up. Let me do it. Okay, so now you can see that the job has been started, and I think this is where I hand over to Harsh to explain what's happening in the background.
Let's go to the slides. Check. So I'm going to take you through the life of a bench test, and I will explain the full procedure. So when a maintainer wants to benchmark a PR, he will mention the release version he wants to benchmark it with. The default version is the master branch, but he can also benchmark it with any previous release. So GitHub will send this webhook event to Prow, and on receiving this event, Prow will create a Kubernetes job. This job uses the PromBench tool as the container image. So as Krasi showed, the prom bot, it printed the acknowledgement, and now the two versions of PromBench of Prometheus are being benchmarked. And if we look at the comment at the status, so a job by the name of start benchmark was started by Prow. Now let's see what does this job actually do. So first thing, this PromBench tool, it will create a new node pool. Node 2 and node 3, they will be used to run the two Prometheus version that are being benchmarked. We did this because we want to dedicate one node completely to Prometheus, because we don't want any other pod interfering with the benchmarking results. And in node 1, these are a bunch of nodes. They will contain many fake web servers. And we also have a load-gen scaler and load-gen querier, which we use to put load on the Prometheus servers. So the Prometheus servers being benchmarked, they will discover the fake web servers. And then we have load-gen querier. So this load-gen querier will constantly query the two Prometheus servers with complex PromQL expressions. It will also expose metrics which tell us the time taken by Prometheus to give the results. We need this because we also want to see in how fast does Prometheus give us the query results when it is under high load. Then we have got a load-gen scaler. This will constantly scale the fake web server pods up and down from 300 to 700 and back to 300 and so on. So with this, and all this will be done in a new namespace in the cluster, and we will use the PR number as the name. So with this, we can run many different benchmarking instances on the same cluster itself. So let's okay. So let's see. Okay, so our as you can see, we use the tool to create the node pool, and right now the objects are being deployed. So we'll give it some time for it to be deployed, and I will explain the parts, by the way. Now, to get the benchmarking results, we have one main Prometheus servers, which will discover these two Prometheus servers being benchmarked, and it will also scrape metrics from the load-gen querier. And we also have an Grafana server, which uses the main Prometheus server as the data source, and we have good dashboards which tell us about the benchmarking results. And of course, we have an alert manager. So if we find that there is a lot of difference between the benchmarking results between the PR and the release version we are benchmarking it with, then we want to trigger alerts and tell the maintainer that something is wrong with this PR. And to implement this, we use a custom webhook event, a custom webhook. And on receiving an alert, this will print a comment in the PR conversation itself. So with this, the maintainer can know, okay, something is going wrong and we need to check something. So let's just look at the logs if they're up yet. I think we are okay. A few things are being deployed, so I'll just continue and then. Krasi, can you come here and open it? I can't actually see it. Sorry. Sorry about that. So here we also have a screenshot of the sample results, but I will show you this in the demo. And while the objects are being deployed, I'll let Krasi tell the future roadmap of this project.
Let me just double check. I think maybe by now the test should be ready. Let's just check the logs again. It's done. So if we go to the Grafana dashboard, let's refresh this. And then from the drop-down menu here, we can select the PR, which is 4478, if I'm not, 4487. Is it the last one? Yeah. Ah, I have another screen here. Okay, that's easy. My neck hurts.
Can we change the resolution for the last 30 minutes? Yeah. So let's see how Krasi's PR actually performed. I think there is something wrong here. So as you can see, the yellow one, actually that's the master branch, and the green one, that's the PR that we are benchmarking it with. So as we can see that there are so many more allocations. So now with this tool, the maintainers can easily see, okay, that they can easily test that if there is something fundamentally wrong with the PR. And if this had been accidentally merged, then we would have got a flurry of GitHub issues saying something is wrong with my server, please help, please help. So now with this, the maintainers can also find new ways of optimizing Prometheus or finding bugs under high load. So that means this PR is not quite correct, and some work actually needs to be done on this.
So just to summarize, just with one command, we scaled up a Kubernetes cluster, we deployed so many pieces, we built Prometheus from the PR, and we run it along with another version, and we compare the results. So a lot of things done only in a single command. Okay. So now I will share with you quickly, because I think we only have a few minutes, few things that we want to see happening next. The first thing is you can run this prom bench without Prow. So you can run it on your own Google Kubernetes cluster. You don't need to run it from GitHub. So we'll add it into the README. The next thing we want to add is another job that will just detect for races. It will run Prometheus at high load, and it will just monitor for race exceptions. Then we want to be able to test the service discovery providers, which is something that we're not testing right now, ideally, because we need to actually deploy the actual service discovery providers, which is kind of difficult with Kubernetes in Amazon. Scalability tests. We've been discussing that it will be great to know how much metrics and how much load can a single Prometheus take on a given machine. So this is what we want to implement next, just to sort of push it to its limit and post the results with every new release, so it gives some idea of what people can expect. And quickly, I want to mention a couple of new, the Prom tool has a new debug command. So if you're submitting an issue, please use it. It will create a profile, a Golang profile with some metrics, because it will really help speed up the debugging. The TSDB scan. The TSDB tool also have a scan, which will try to repair or delete corrupted blocks, so that at least Prometheus can start without deleting the entire folder. Now that I see the project almost ready, it makes me believe in open source even more. It was really nice to see how many people helped and how easy it was to get what we needed, just common sense, and so many people have packet. I don't know if I have time. How much time do we have? We're over. Okay. I will let you read this later. And at the end, I want to say I like refactoring, but I hate breaking code. And now with this, I hope I can do what I like without hating what I do. That's another project from my colleagues, because I want to be a team player, so I decided to quickly mention it. It's really cool. It's using Prometheus, Istio, and Jaeger, so really cool. Go and check it out. I recommend it. Kiali on GitHub. And questions if we have time. That's either very good or very bad.
Thank you very much. Great presentation. Since you are benchmarking in the cloud, have you ever experienced inconsistent or strange results due to noisy neighbors or cloudy effects?
It's still early stages. We haven't really run any real tests, but what we're doing is we are deploying Kubernetes itself on a single machine. So every instance of Prometheus runs on its own machine. So it doesn't really have any noisy neighbors, if this is what you mean. I mean, it doesn't run with anything else next to it. So it's on its own on a single machine. So this is how we are trying to get the best results by comparing the two.
Do you only run the benchmarks with Pro or everything else as well, like the whole CI pipelines?
Sorry, can you repeat that?
Do you also run everything with Pro, like the whole CI pipeline?
No, Pro only runs the prom bench tool by passing arguments, which is the PR and which are the two versions you want to compare, and that's it. Just runs the prom bench tool, nothing else. We're using Pro mainly so we can trigger jobs from the comments by passing the PR and the other version that we want to test, a release or a master. One more at least? No?
We got time for one more.
Thank you.
Hi, I'm interested to know how you built the queries that you load test with.
Well, the queries, this is the second version of the prom bench. The first one was built by Fabian and Max, if I'm not wrong, kind of. So the queries are from the first version, so I don't really know. We just reused it. But all the code is in prom bench. In components, you will see the queries there. It's like a simple text file, and you can see it there. So if you go to prom bench, just browse around, and you will find it.
Yeah, is there potential ability to shoot here? I'm here. Hi. Is there potential ability to shoot this benchmark against my own deployment of Prometheus, so to predict how much load it can handle?
This is on the roadmap. This is like the scalability test. At the moment, the only thing I can say is that it's so easy to run. You can run it in your Google Kubernetes account, but at the moment you can only choose between two given versions, a PR, a master, or a release and master. I think what you're referring to is a scalability test, which is how much it can, a single Prometheus. It's coming. We know it's important, so we'll try to do this next.
All right, thanks.